Hey guys, Mr. Backberg here. In this video, we're going to look at polynomial inequalities. So in this example, we're going to look at a polynomial function, and what we're going to do is look for where our function is equal to 0, where it's positive, and also where it's negative. And I'm going to give you a function that's written out in its factored form. So we're going to look at f of x equals x plus 3 times x squared plus 1 times x minus 4 squared. And the first thing I want to do is look for where this polynomial function is equal to 0. So it's just like finding the zeros of a function. Since this is written out in its factored form, what I could do is I could take all of my factors and set them equal to 0. So I would take the x plus 3 and set it equal to 0. If I solved that, I would get x equals negative 3. If I tried to take the x squared plus 1 and set that equal to 0, I would have to subtract the 1 over to the other side, so I would get x squared equals negative 1. But then I would have to try to square root that, and I can't square root negative 1. So that factor doesn't give me any zeros. And then my last two factors, since I have x minus 4 squared, we would take the x minus 4 and set it equal to 0. I would add the 4 over to the other side, so I would get a 0 at x equals 4. But since this is a squared term, we're technically getting x equals 4 twice. So my function is equal to 0 at the x values of negative 3 and at 4. But if I want to look at where my function is positive or negative, I'm going to create a sign chart using a number line. Now what I know is that my function is going to be equal to 0 at negative 3 and at 4. So I'm going to highlight those places on my number line. So right here at negative 3, I know that my function is going to be equal to 0. And right here at 4, I know my function is also going to be equal to 0. But I want to look at what's happening to the left of negative 3. I want to look at what's happening between negative 3 and 4. And I want to look at what's happening to the right of 4. So if we first want to look at what's happening left of negative 3, then I would want to plug in a value for x that's less than negative 3. So we can pick out a test value, maybe an x value of negative 4. And what I'm going to do is I'm going to take that and plug that in for my x's within the function. So in that first factor, I would get negative 4 plus 3. And then in my second factor, I would get negative 4 squared plus 1, and in my last factor I would get negative 4 minus 4 squared. Now if I think about what's happening within each set of parentheses, negative 4 plus 3 is negative 1. In the middle here, if I take that negative 4 and square it, I'm going to get 16, but then if I add 1 to that, I'm going to get 17. And then on the back end here, if I take negative 4 minus 4, I'm going to get negative 8, but negative 8 squared is 64. Now I have to remember that we're multiplying all of these values together. So if I take negative 1 times 17 times 64, I'm not so much concerned about what the actual answer is, but what I want to know is my answer positive or negative? And because I'm multiplying two positives together with a negative number, then my answer is going to be negative. So what that tells me about my function is for every x value left of negative 3, my function is going to be negative. Now if I want to plug in something in the middle, something between negative 3 and 4, 0 is a nice number to use, so I'm going to take x equals 0, and I'm going to plug that into my function. So I would get 0 plus 3, and then I would get 0 squared plus 1, and then I would get 0 minus 4 squared. Now in the front here, 0 plus 3 is 3. In the middle, 0 squared is 0 plus 1 is 1. And on the back end, 0 minus 4 is negative 4. But if I square that, I get 16. Now again, I'm not so much concerned about what the answer is when I multiply all these things together. I just want to know if it's positive or negative. So since I'm multiplying three positive numbers together, my answer is a positive number. So for every x value between negative 3 and 4, no matter what we plug in there, we will always get a positive result. And then if I look at numbers to the right of 4, so say we picked an x value of 5. And again, I'm going to take that and plug that into my function for the x. So if I went 5 plus 3 times 5 squared plus 1 times 5 minus 4 squared. On the left-hand side, that's going to be 8. In the middle, 5 squared is 25, plus 1 is 26. And on the back end, 5 minus 4 is 1, and 1 squared is 1. And again, I don't care what the answer is when I multiply them together. I just want to know if it's positive or negative. We're multiplying 3 positive numbers together, so no matter what value we pick to the right of 4, my function will always be positive. So what we came up with on our sign chart, if we plug in a value that's less than negative 3, we're going to get a negative result. If we plug in negative 3 itself, we said earlier that that would give us 0 as an answer. Anything between negative 3 and 4 will always give us a positive answer. If we plugged in 4, we would get 0 since it's a 0 of our function. And if we plug in something to the right of 4, so bigger than 4, we're always going to get a positive result. And I'm going to graph this out on my calculator just to confirm it. So in my calculator, I have my function typed in. I am going to adjust the window a little bit just so we can see our behavior. I set my y minimum at negative 100, and I set my y maximum at positive 200, just so we can see some of the behavior of our graph a little bit better. So when I hit graph, we'll get a picture that looks something like this. Now we can see those zeros happening at negative 3 and at 4, but we also were concerned about where our graph was positive and where it was negative. So if we go to the left of negative 3, we can see that our graph is below the x-axis, meaning that those y values would be negative. Between negative 3 and positive 4, my graph is above the x-axis, so it's positive. At 4, we're back at 0. But then after 4, as we move to the right of 4, our graph is also above the x-axis, so those y values would be positive. So this graph confirms the behavior that we said was going to happen within our sign chart. So now in this example, we're going to take a look at solving a polynomial inequality analytically. And we're going to look at the inequality 2x cubed minus 7x squared minus 10x plus 24 is greater than 0. Now, just like we did on the last one, what I want to do is I want to figure out where my function is going to equal 0. So I'm actually going to do a little synthetic division. So I'm going to use my rational zero theorem to help me out. If I look at the factors of the 24 on the back end, we would have plus or minus 1 and plus or minus 24. We would have 2 and 12. We would have 3 and 8. And we would also have 4 and 6. And then if we look at the factors of the leading coefficient 2, that'd just be 1 and 2. So we've got a big long list of possible zeros of this function. Now we can look at a table or we can look at a graph to help us figure out which ones would actually be zeros. I'm going to run synthetic division in here. And I'm going to use 4. So I'm going to drop down the 2. I'll multiply, then I'll add and multiply and add and multiply and then add one more time. So 4 is in fact a 0 of my polynomial. And then what I can do with this is I started with a cubic function. I did one round of division, so now I've got a quadratic 2x squared plus x minus 6. And this is actually factorable. We can factor this into 2x minus 3 and x plus 2. So then we would see that we have zeros at x equals negative 2 and also at x equals 3/2, along with that 4 that we had earlier. So x equals 4 there. Now I'm going to make a number line just like we did on the last one, and we're going to create a sign chart using that number line. So I'm going to highlight the zeros of my function on this number line. So negative 2 is right here. Then we would have 3/2, and then we would also have 4. Now we know that our function is equal to 0 at all of those values, but we're going to look for where our function is positive and where it's negative. Because remember, we're trying to figure out where our function is greater than 0. So that's going to mean positive to us eventually. Now, in the last example, when we were making a sign chart, we picked some test values, but I want to look at this one just a little bit more analytically, just thinking about what's happening in here. So we know that we have a positive cubic function, meaning if we're just thinking about the graph, the left-hand side would need to go down and the right-hand side would need to go up. So we start below the x-axis. So everything on the left of -2 is going to be a negative value. Now, as we're looking at how these zeros are happening, and if we think about their multiplicity, each one of these has a multiplicity of 1, meaning that our graph is going to cross through the x-axis at each one of these values. So if I'm starting below the x-axis and working my way up, knowing that I have to cross at -2, then my function will be above the x-axis, making it positive between -2 and 3/2. But then our graph is going to have to turn back around because we've got another 0 happening at 3/2. And again, we've got a multiplicity of 1 there, so our graph is going to have to cross through the x-axis. And now it's going to be below the x-axis, so these values are going to be negative. And then we're going to have to turn around one more time because we're supposed to have another 0 at 4. And again, because the multiplicity is odd, my graph has to cross through the x-axis at that point. So everything to the right of 4 is going to be positive as well. Now, if we want to look at where our function is greater than 0, then it's happening at 2 places. It's happening between -2 and 3/2, and it's also happening from 4 all the way out to the right-hand side to positive infinity. So on these two intervals, my graph is above the x-axis, so it's positive there. Now I'm going to graph this one out on my calculator just to confirm this behavior. So in my calculator, I have my function typed in. If I hit graph, then we can see that we have those zeros happening at -2, at 3/2, and at 4. I can see if I look left of -2, my graph is below the x-axis, so it's negative there. Between -2 and 3/2, it's above the x-axis, so it's positive. Between 3/2 and 4, we're below the x-axis again, so we're negative there. And then to the right of 4, we're above the x-axis, so we're positive. And again, we were trying to find where this function was greater than 0. So we would be looking for where our function was positive or above the x-axis. That's going to be it for this video. Thanks for watching.